Okay, now we're going to finish up chapter 5. This next test will be a cumulative test. It'll cover everything the other test covered plus the rest of the chapter. So we're starting today. This is section 5.5. And it's called Properties of Integrals. Good thing I haven't done attendance yet. All right, properties of integrals. Some of these you already know, and it's also and average value theorem. I can't spell. Average value theorem. Average value theorem is the mean value theorem of integration. You remember mean value theorem? When y'all did that one? You were finding the value where the slope was the same as the derivative for a secant. Well, now we're going to do the equivalent going the other way with area. All right. First, we're going to go over stuff that we went over back when we did this. Remember at the very, very, very beginning when we had area, that area worksheet where we had definite integrals and y'all had to add up the circles and the squares and all that stuff? Okay, we talked about even and odd then. This section covers even and odd. And when you have an even function, it means that it's x squared, x to the fourth, a number like 4, cosine of x, and what's the other trig function that's even? That has a cosine only in it? Secant. Those are all even functions. What does that mean? It's symmetrical across what? Yeah, y-axis. Our favorite one is, Lord, what is it today with everybody being late? Our favorite one is the parent function, y equals x squared. Is that one definitely even? It is most definitely even. And what that means is, for purposes of integration, if I'm going from negative a to a, these two areas are exactly the same size. And it means that the integral from negative a to a of an even function dx is equal to, let me erase that, is equal to the integral from 0 to a, double it, of the f of even x dx. Right? If it's an even function, I can go from 0 to a and double it. And why is that important? Because there are times when you have the information for 0 to a and they want you to find it from negative a to a. Can you just double what you're given? Make sense? It's shortcut also if you're doing integration and you want to speed things up a little bit, but for the most part, if you can evaluate a, you can evaluate negative a easily in them, most of the time. Okay, what about odd functions? Odd functions, x cubed, x to the 7th. What are trig functions? Sine, everything else. Cosecant x, tangent of x, right? All the rest. They're all odd. So our favorite one we like to graph is sine, because that's a nice odd one. We graph sine. Do you all agree that it goes like this? If I go across the origin, there's all this region down here and all this region down here. And this is negative and this is positive. We are going from, this is from negative pi to pi for sine. Does that mean it's the negative a to a for any generic function that is odd? What are odd functions symmetrical across? No. How about the origin? It means if it's 1, 1, that means it's going to be -1, -1. Do you see what I mean about symmetrical across the origin? And because there's as much area below as above, if I'm integrating from -a to a, what is my answer going to be every single time? 0. Is that coming really, really handy? That one is very useful. Because there are times when you can take out the part that's odd and say, that's all going to go to 0 since I'm going from -2 to 2, or whatever it is you're doing. So for this one, if you are integrating, what is it today? Y'all are awful today. Some function that is odd, f of x, right? You sure you don't want all of them?
No.
Okay.
But here's
She's here.
all right, thank you.
Yes. dx is equal to 0 every flippin' time. And it is most important in information you are given, when you're given part of it, and they want you to find the whole interval. That is when this is most useful. It's kind of useful when you're integrating just to know it, because so when you get the result, you're not surprised. So examples. Examples are, if I integrate from -2 to 2 of x to the 4th minus x squared plus 2 dx, what is that going to equal? Double my integral from -2 to, sorry, not -2, 0. 0 to 2 of x to the 4th minus x squared plus 2 dx. And why is that an advantage for y'all? Not for me, but for y'all. Why is that an advantage? Because you don't have to evaluate a negative number. And y'all tend to mess up negatives, right? Because it's negative to an odd power, which means it's going to be negative. And since I'm subtracting, is that going to be a problem? And sometimes you mess that up. Will that be an advantage for you? Possibly. Okay, what if you're given something like -pi/2 to pi/2 of cosine of x d, sorry, I'm going to say cosine theta. I'm going to make it a big deal. It's an angle. Once again, evaluating -pi/2, is it so much easier just to evaluate pi/2? Okay, is cosine even? Yeah, so is this going to be 2 integral from 0 to pi/2 cosine theta d theta? Is that going to be so much easier because what's the integral of cosine? Sine, so does it become 2 of sine of theta, sorry, theta, evaluated from 0 to pi/2. And what's that equal? It's going to equal 2 times sine of pi/2 minus sine of 0, which equals, well, what is sine at pi/2? That's 1. What's sine at 0? That's 0. So does this equal 2?
É tão fácil.
That was not. Oh my God, that was not. That was French. É tout facile.
É tão fácil.
It is easy. No, that's. Oh, stop. Just stop. Okay, whoa, shh. But wait. When are you really going to need this? Those are all fun and great, but what if you are given, and they say, an odd function? And you're also given that the integral from 0 to 4 of f of x dx is equal to 3. And you're also given that the integral from 0 to 8 of f of x dx is equal to 9. And I want you to find, it is, if you know what you're doing, I want you to find the integral from negative 4 to 8 of f of x dx. Uh-huh, yeah. Uh-huh, there's a problem in there. I guess you need to figure something out. Okay, have you all got it written down? Because I've got to go to the next page. Write it down. Everybody written it down? Okay, so what is that going to make it? So do we all agree that we have from 0 to 8? Do I need from negative 4 to 0?
Yes.
So the integral from negative 4 to 8 of f of x dx is going to equal the integral from negative 4 to 0 of f of x dx. Sorry. Plus the integral from 0 to 8 of f of x dx. And I have all that. Did you know you had that?
Yes.
You do. Do you have from 0 to 4?
Yes.
Is it an odd function? Yeah, it is. So can I get this by subtracting out? So I need this. Can I get this from what I have and something I know? Do we all agree that the integral from negative 4 to 4 of an odd function is equal to 0, right? I have from 0 to 4, I want from negative 4 to 0. Can I just subtract it? Right? So if I want, let's write down what we know. We know from 0 to 4, f of x dx is equal to 3. I know from negative 4 to 4 is 0. I know from 0 to 4 is 3. Do I just need to subtract those to get from negative 4 to 0? Yes. So what's 0 minus 3? Okay. So that means that this integral from negative 4 to 8 of f of x dx is going to equal, I got that, that's negative 3, right? Negative 3. And then they told me that from 0 to 8 is 9, so is that equal to 6?
É tão fácil.
Just in case you didn't catch it the first time.
Why can't you just do from 4 to 8?
Huh?
You could just start from 4 to 8, right? Or is that?
You could also do that. I'm making a big deal of, you could all, if you know from negative 4 to 4, then you could also do the 0 to 8 minus the 0 to 4. You could also do that. That's another way to do it. Either way works. But you still have to take into account that from negative 4 to 4 is 0. Right? Okay. Now moving on. Now we need to do the average value theorem. To do the average value theorem, I need to go back and do mean value theorem. And I need to show you it's the same thing. It truly is. So to do this, I'm going to draw a graph of an easy function. I'm going to draw a graph of y equal x cubed. But I'm going to only draw part of it. I'm going to draw from 0 to 1. And is it curved like this? Is that what y equal x cubed looks like? It's not to scale, but it's close enough. Back when we did mean value theorem with derivatives, we said that if we pick some point between, in our interval, this is my interval, right? This is A, this is B, this is going to be some point C, and we're going to draw a tangent line in. That tangent line is equal to it's got the same slope as the secant. I drew it that way on purpose. You see what I'm getting at? What did we say? How did we write that before? Remember when we did this, right? Secant has the same slope as the tangent line. That means the slope of the tangent line, which is f prime at C, has got to equal the slope of the secant, which is f of b minus f of a all over b minus a. Remember that? Everybody remember?
I accidentally kept one pass over this one.
Thank you.
Thank you, sorry.
And what was this looking for? This is looking for, we wanted the average rate of change. Over the interval from 0 to 1. Remember those problems? And we get the secant equal to the tangent. Did we just take its derivative? So what's the derivative of yx cubed? Y prime is equal to 3x squared. Agreed? And when we did this, did we go, okay, that has to equal f of 1 minus f of 0 all over 1 minus 0. Which f of 1 is 1, f of 0 is 0, so it's 1 over 1 is 1. Right? Not real hard. That was the slope of 1. Did we go and find c? We did. So when you set that equal to each other, you got 3c squared equals 1. That means c squared equals 1/3. That means c is equal to the square root of 1/3. Remember that? Remember doing that? Please say yes. Sorta. It was a long time ago. You need to remember this. Why do you need... Here, let me back up. Do y'all need to see that? Why do y'all need to remember to do this? Because when we get to the AP test, they're not just going to ask you for average rate of change and where it occurs at. They're going to ask you for average value. Do you have to know the difference? If we're talking about average rate of change, is a rate of change the slope and is slope derivatives? Right? What's an integral? What's the magic word? What? Area. When we first started this, did you find the area of rectangles and quarter circles and triangles and rectangles? Was integrals area. Slope is derivatives, area is integrals. So when they ask for average rate of change, you're doing a derivative. When they want average value, you're going to do an area, and I'm going to show you why. Okay, suppose we go backwards on this. Same thing. Do we agree that the derivative is 3x squared? Okay, if I do its area, I need a new page. So now I'm going to draw 3x squared. Maybe. I'll sketch it. It ain't going to be gorgeous. All right, at 1, we're going to just make this 3, right? Still does this. This is y equal to 3x squared. It's just a stretched parabola, yes? Okay. I am going between 0 and 1, but now I want to find the average value over the interval from 0 to 1. Does it look a lot like average rate of change? It is. In fact, they're related. Now, instead, so I've got this interval, so I got this area under the curve, right? You could find that area. The average value that corresponds to that is the rectangle that has the same area and the same width. You can pass it across. Who is it?
Yeah, no, it's-
In a minute. Okay, so the whole point here is now we're going to find a rectangle that has this same area, and it's going to happen at some C value. It's going to happen at the C value right here, C. This rectangle has the same area under the curve as my integral, my curve. This is some f of c. So we want to find the c that gives me the same area. So now we know that that's the derivative, right? This is f prime of c, right? If I want to find the area under the curve, do I have to integrate it? If I want to find the area of that rectangle, am I just going to multiply this width by that function value? And that function value is actually what? It's actually the derivative, right? We're graphing the derivative. Yeah? Actually, no, just leave it as f of c. Just ignore me. I'm just saying up, it's the same as the derivative up above. So here's what's going to happen now. To find this value, we have that function value at C times the width, which is b minus a. This is a, this is b, right? B minus a. Do we agree that that's the area of the rectangle? Yeah? And to write the area of the curve, are we integrating from a to b of f of x dx? Or f of x dx. Right? Agreed? That'd be that whole area. If I want to find the average value, that's what the f of c is, do I have to divide by b minus a? So f, the average value, this is average value, is equal to the integral from a to b of f of x dx all over b minus a. And let's think about what this means. This on top is that area. This is area under the curve, right? This is a width. If I divide the area by the width, do I get the height? Is that the average value? Is the height on those rectangles a value, which is a y value? Yeah? Guess what? Since I am now integrating the derivative from the one above, I'm going to get the same c. Watch and be amazed. First off, to find that average value, that f of c, we're going to find that first, right? So we got f of c times b minus a, which is 1, right, is equal to the integral from 0 to 1 of 3x squared dx, right? What's the antiderivative of 3x squared? X cubed evaluated from 0 to 1, which equals 1. What's 1 divided by 1? 1. So I want to know when f of c equals 1. That means that 3c squared, which is f of c, equals 1. So c squared equals 1/3. Have we seen this before? C is equal to the square root of 1/3. And I'm picking the positive one. Why am I picking the positive ones? Because I don't want a negative area. Right? Did I get the same c? I did, because those are related. If I'm talking about the average rate of change, and then I do average value of the derivative from average rate of change, I'm going to get the same c. They are related. It's going backwards. I just wanted y'all to see that, because I think it's cool. It's cool to understand it. It's okay. It may take a while before it sinks in. You may have to do some of this before you, that may not make sense to you for a while. But they are related. You just have to, when I ask for average rate of change, what is the rate of change? Slope. When I ask for average value, it is a area. Okay? So, just to summarize, average value. That's f of c equals the integral from a to b of f of x dx over b minus a. So it is area divided by a width gives me the height of the rectangle, which that's the value. Very, 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 very important. It's called a theorem. Are those theorems important? At some point, you might have to justify your answer based on that. At a very least, you're going to have to find something and justify your answer based on this. What do these problems look like? Example 1. And later on, I will mix them all up, but not right now. We got to learn to find them first. And eventually, am I going to mix them all up and give you average value and average rate of change and mix them all up and make you find them? Yes. Find the average value of f of x equal to 3x squared minus 2x over the interval from 1 to 4. Is that the question? That's all they're going to ask you. What do you think? You gotta go. When you see average value, when you see value, you gotta think area, which means integral. When you see rate of change, average rate of change means slope means derivative. All right, so what do I need to do? I need to find f of c, whoops, writing a little messy. F of c equals the integral from what to what? 1 to 4 of what? 3x squared minus 2x dx all over what? 4 minus 1, which is 3. What is the antiderivative of 3x squared? What's the antiderivative of? So is that really easy? Evaluated from what to what? To 4 all over 3. Okay, do you know your foursies? Hang on, I gotta change page. Y'all have that all written down first before I change pages. What's 4 cubed? You don't have to know it. I'm gonna show you math. You can do it, but I mean, if you know it, great. If you don't, I'm gonna show you some number sense. You ready for it? Okay, this ought to be good. Here we go, number sense. So we now have f of c is equal to, I'm going to rewrite what I had, x squared, evaluate from 1 to 4 over 3. That means it is 4 cubed minus 4 squared, right? Minus 1, agreed? The 1 minus 1 is just 0, yes? That goes to 0. Okay, for the 4, is this 4 times, can I pull out a 4 squared out of both of those? Will you agree? And then, does that mean I have 4 minus 1 left over? All over 3? And look what cancels out. It's called number sense, and it's amazing. You should try it sometime. Was that slick or what? See, I really despise making numbers big only to divide and make them small. So I do my best to eliminate stuff beforehand so that my head doesn't, I don't waste any effort on making numbers big only to make them small. If y'all could factor, it would be amazing. Really, really. And that's it for today. I think that's enough. What do you think?
Wait, so how do you find F of C now?
If I wanted to find C, I would set, that was not the question. They would, I would set the original function, what was I doing? I would go back and instead of doing that, I would, oh, you set the original function equal to 16. If I were to find C, just for if we want to find C, what do we have for f of C? What do we have for our function to begin with? So it would be 3x squared minus x minus 2x equal to 16. That's it. Okay? But we're not doing that. Not on this problem.